So this time we're going to talk about finding solutions within the interval 0 to 2 pi. So this little line means that 0 is included in the interval and 2 pi is not, which simply means that if you're talking about this angle over here, we're going to call it 0 and not 2 pi, or not both 0 and 2 pi. Okay, so what we do is we start out by writing our equation here. 2 times the cosine of theta is equal to -1. Now we want to isolate the trig function, much like we isolate an x when we're solving for x. So we've got cosine of theta is equal to -1/2. So we're trying to find all of the angles between 0 and 2 pi where your cosine is -1/2. Well, your cosine is -1/2 at that angle here, which is 2 pi over 3, and this angle here, which is 4 pi over 3. And I mean that if you look at your coordinate pair, cosine comma sine, you've got -1/2 positive √3 over 2. And on this angle 4 pi over 3, you've got -1/2 negative √3 over 2. So we're looking for the cosine being -1/2. So it occurs when theta is equal to 2 pi over 3 and also 4 pi over 3. So there's two angles in the interval 0 to 2 pi who have the cosine -1/2. So here's another simple example. This one says find the solutions of sine theta is equal to -1/2 in the interval 0 to 2 pi. So your interval here is given to you in a different way. It's given to you in interval notation. So if your angle 0 is part of your solution, you want to call it 0 and not 2 pi. That's what this is saying. So we're not going to call it 0 and 2 pi. We're not going to call it 2 pi. We're just going to call it 0. So we start out by saying sine of theta is equal to -1/2. So we're simply asked to find where are all the angles where the sine is -1/2. So this time sine is -1/2. So this is -√3 over 2 -1/2. And this is √3 over 2 -1/2. So this angle here would be 7 pi over 6, and this angle here would be 11 pi over 6. So I'm going to list these two solutions. 7 pi over 6 and 11 pi over 6 are the two angles between 0 and 2 pi who have the cosine equal to -1/2. I meant to say who have the sine equal to -1/2. All right, let's do a tangent problem now. This one says find the solutions of tan x divided by √3 is equal to 1 on the interval 0 to 2 pi again. So let's write the equation. Tan x over √3 is equal to 1. So we want to isolate the tangent of x. So I'm going to multiply by √3 on both sides. So I can isolate my tangent of x. So I'll have tangent of x is equal to √3. So that means the sine of x over the cosine of x is equal to √3, or √3 over 1. All right, so that means there is going to be this setup. If you think about this for a minute, √3 over 2 divided by 1/2, where that 2 right here is going to cancel, and you'll have √3 on the top and 1 on the bottom. So we're going to look for the places where your sine is √3 over 2 and your cosine is 1/2. So your sine is √3 over 2, so that means we'd be, let's see, sine is √3 over 2, so that'd be here. So we've got sine and cos, so 1/2 root 3 over 2. All right, so this is your sine. And of course, this is your cosine. All right, and then we've got that again down here. All right, so just straighten that line out. We've got that down here. We've got two negatives this time. So we've got cosine is negative 1/2 and sine is negative root 3 over 2. So it doesn't really matter whether you've got the plus or the minus, because a minus over a minus is a plus, and a plus over a plus is a plus. So both of those angles right there. So let's see, this one here would be pi over 3, and this one right here would be 4 pi over 3. So there's two angles that have a positive tangent equal to root 3. So the way I would write that solution is that theta is equal to pi over 3 and 4 pi over 3 in that interval. All right, so those are the most basic, simple kind of equations where you just basically have a one-step solution.